everyone, welcome to online instruction. This is going to work a little bit differently than teaching in the classroom. I'm going to have the notes uploaded onto my Microsoft Teams. So make sure as you're watching this video, you are printing out a copy and writing them down, trying some for yourself. I'm going to do the first page of this notes with you. I have some practice on the back. Try those. I'll put a key up. Test yourself. And then at the end, I'm going to have a little 5-question checkpoint on my Microsoft Teams. It's all underneath the same assignment. I'll put directions on how to get to the assignment on my website. All right, so today we're going to be working on scientific notation. So scientific notation is essentially a way we write really big or really small numbers. So something like the population of people on Earth, we write that as 7.0 times 10 to the 9th because it's a really big number. And we're going to talk about exactly what that times 10 to the 9th means. Same thing with the speed of light in kilometers per hour. That's really, really fast, so that number is going to be really big. The size of a single red blood cell, that's really small. And the difference here is that we have a negative exponent as compared to these positive. And what that indicates to us is that a negative exponent represents a really small number, while positive exponents represent really big numbers. And the amount of stars, there's a lot of stars in the solar system, so that's going to be represented by scientific notation. So why do we need scientific notation exactly? To write large or small numbers, really large or small numbers. So what does scientific notation look like? It starts off with a number in the front, a decimal. That decimal is between 1 and 9. You have, let's change this color here. Go with the green. You have multiplication in the middle. You have a base of 10, meaning it's always multiplied by 10 to some power. And again, as we said before, the bigger that number, the bigger and positive that number, the larger that number is going to be. The smaller the number, the more negative the number, not the smaller, that's going to be the smaller the number. So I want you to take a minute, look at these 3 numbers below, and ask yourself why these numbers aren't written in scientific notation. So if you need to, take a minute, pause the video, check it out. So this first guy isn't in scientific notation because, as we said before, that number in the front has to be between 1 and smaller than 10. This guy's a 20, so that's not proper. The second one, we said we needed a base of 10 connected to that exponent. Here, we have a 20. And this one, we said we needed multiplication between the two. That's addition. So I'm going to go through a couple of examples with you of how to convert numbers from standard notation. Standard notation is just normal numbers we're used to seeing, to scientific notation and back. So say we're given a number like 3,750,000. If we want to write that number in scientific notation, the first thing we would do is identify where that decimal is supposed to be. And the decimal is supposed to be at the end of the number. Now, if you look at the 3 examples we have up here of scientific notation, this number is between 1 and less than 10. So we're going to move that decimal until it's between the first 2 numbers we see, 3 and 7. So that makes it 3.75. What'd I click? There we go. We always have a multiplication sign in the middle, a 10, and then to get that exponent, what we need to do is count how many times we move that decimal over. So notice how we have 1, 2, 3, 4, 5, 6 little bumps. So the exponent's going to be 6. If it's a really big number, that exponent's going to be positive. If it's a very small number, that exponent is going to be negative. So let's take a minute and write down the steps we took. The first thing we did is we moved the decimal. Let's see if we can type this. Press the text button. Ooh, never mind. Let's just write this. Oh no. What did I do? I am new to this app, so there's gonna be some flaws. It's okay. Take it step by step. We're all new to this. All right. So the first thing we're gonna do is move the decimal between first two numbers we see. First two numbers. Then we write it as that decimal, something between 1 and 9.9, times 10 to some power. And that power there is going to be the number of times we moved. If it's positive, or if it's a large number, exponent's going to be positive. Small number, the exponent's going to be negative. So just some things to keep in mind as you are solving these kinds of problems. So let's see the other way when we're going from scientific notation to standard notation. Pick a new color to keep things interesting. Go with a nice blue. So if we have something like 2.76 times 10 to the fifth power. The first thing we're going to want to do is write that decimal below. This 5 here, this indicates how many times we're moving the decimal. If it's positive, we're going to go to the right. If it's negative, we're going to go to the left. So since it's positive, we're going to move it right 2, 3, 4, 5 times. And with those empty bumps, we're going to fill in zeros. So 2.76 times 10 to the fifth power is really 276,000. So let's take a minute and write those steps. So what was the first thing we did? We moved that decimal exponent number of times. And if it's positive, means we go to the right. Negative means we go to the left. The second thing we want to do is fill in bumps, in quotes, with, oh no, clicked something. There we go, with zeros. And that's how you convert your number from scientific notation back to standard notation. So here are your notes. I have a whole page of practice on the back or on the next page of the PDF. Make sure if you don't understand something, you reach out to me. I created a Remind app. You can send me a message on Remind. We can set up a video conference on Microsoft Teams, whatever you're comfortable with. I just want to make sure you understand this. All right, so stay safe. I will have another lesson up for you for 2 days from now, day 13. Stay safe and healthy. Bye.